Imagine living on a planet, but knowing only a small part of it. We search for life in places millions of kilometers away in space, and we send spacecraft to other planets. While right here, on our own planet, a vast and mysterious world stretches beneath the surface of the water. The oceans cover around 71% of Earth's surface, with an average depth of about 3.7 kilometers, and at the deepest point, the seafloor lies nearly 11 kilometers below the surface. But here's the strange part. Reaching these depths is not impossible. We have submarines, robots, and cameras. We have sonar and advanced technologies for mapping the ocean floor. We can even track some of the animals that live in this mysterious world. So why, despite all this scientific and technological progress, are vast parts of the deep ocean still beyond direct exploration? Is it the darkness, the immense pressure, or does the sheer size of the oceans make exploring them in their entirety an enormous challenge? And the bigger question is, with all these advanced technologies at our disposal, just how far can we go in exploring the depths of our own world? Today, we're diving into the depths of the ocean to discover why this incredible world still holds so many secrets. Let's start with the fact that makes exploring the ocean far more complicated than it seems. When you look at a map of the world, you might think that land makes up most of our planet, but the truth is very different. Water covers around 71% of Earth's surface, while land accounts for only about 29%. That means most of the planet's surface isn't land we can walk on, but a vast world hidden beneath the water. But the challenge isn't just about its size. The ocean isn't simply a layer of water covering the Earth's surface. It's a three-dimensional world, stretching from a sunlit surface to depths plunged into complete darkness, where the pressure rises to enormous levels. And the deeper we go, the more everything changes. Sunlight gradually disappears, temperatures drop throughout most of the deep ocean, and the pressure of the surrounding water increases dramatically. At the same time, we don't have a detailed map of everything in this vast world, and we can't simply send teams of humans to cover such an enormous area, piece by piece. Yet, that doesn't mean the ocean remains unexplored. Scientists have reached the deepest parts of the ocean, mapped vast areas of the seafloor, filmed creatures living in extreme conditions, and discovered entire ecosystems thriving in darkness. But every new discovery leads to another question. If we can actually reach these depths, why don't we simply go down there and explore them, just as we explore any other place on Earth? That's where the real challenge begins. Imagine standing on the surface of the ocean, then beginning to descend into the depths. At first, it doesn't seem very different from an ordinary dive. But with every meter you descend, the water around you presses against you more and more. At a depth of around 10 meters, the surrounding pressure is already twice that at sea level. And as you continue descending, the pressure keeps increasing. Thousands of meters below the surface, the pressure becomes so immense that even a small weakness in a vehicle not designed for such depths could cause its structure to collapse under the force of the water. But pressure isn't the only problem. The farther we move from the surface, the more sunlight gradually disappears, until we reach depths where sunlight cannot reach at all. There is no day or night in the way we know them, only permanent darkness. And throughout most of the deep ocean, temperatures are also very low. While vehicles must operate in an environment where humans cannot survive without advanced protection and life support systems. Then there's another problem that's less obvious. Communication. On land, you can send a signal through a phone or radio almost instantly. But underwater, radio waves don't work in the same way, making communication with vehicles operating in the depths far more complicated. So, if we want to explore this environment, sending humans down there is not a simple task. But perhaps we don't need to send humans at all. If the human body can't withstand these conditions, why not send something that can? A robot, a camera, or a vehicle that can be controlled from the surface. And that's exactly what scientists and engineers began developing. So, instead of sending humans into an environment that could be dangerous to them, we began sending machines. Today, robotic vehicles have been specifically designed to explore the depths of the ocean. Some are known as remotely operated vehicles, or ROVs. They are connected to a ship on the surface by a long cable that carries power, data, and commands between them. There are also autonomous underwater vehicles, known as AUVs, which can move underwater and carry out specific missions without being directly connected to a surface vessel. These vehicles are equipped with cameras and powerful lights, and they can carry sensors and scientific instruments to collect data and study their surroundings. Thanks to this technology, scientists have reached enormous depths, filmed the seafloor, and studied creatures living in environments where humans cannot survive. So, have we found the solution? We have vehicles that can descend into the depths. We have cameras that can film in the darkness. We have lights that can illuminate what lies ahead. And we have instruments that can collect data and send it back to the surface. So why don't we simply send these vehicles everywhere and explore the entire ocean? Here, a new problem emerges. Imagine placing a camera in the middle of a huge city and turning it on to film the entire city. You would only see what's around the camera. Now imagine that this city isn't just one city, but an ocean covering more than 2/3 of an entire planet, extending several kilometers into the depths. Even the most advanced exploration vehicle can only see a limited part of its surroundings during each mission. So the problem is no longer simply reaching the depths. It's knowing what's beyond the camera's field of view. But perhaps we don't need to rely on light alone to see what is hidden in the darkness. What if we could see using something completely different? Sound. Deep in the ocean, light cannot reach everywhere. But sound is a different story. Sound waves can travel long distances underwater, which is why sonar has become one of the most important tools for exploring the oceans. The idea behind sonar is simple. The device sends a sound wave through the water. When that wave hits an object or the ocean floor, part of it bounces back to the receiver. By analyzing this returning echo, scientists can determine the location of objects and estimate distances. Sonar can even be used to map the seafloor and detect things hidden in the depths. This means we no longer have to rely on light alone to find out what is hiding in the darkness. But sonar doesn't always give us a detailed image like a camera does. Instead, it provides information and signals that need to be analyzed and interpreted. That's why researchers combine sonar with cameras and other sensors to build a more complete picture of the underwater environment. And yet, another problem remains. Even if we know that something is there in the darkness, where do we look for it in the first place? The ocean is enormous, and marine animals are constantly moving. So what if the best clue leading us into this unknown world is something that already lives there? Marine animals. Marine animals have lived in this world for millions of years. They move across the oceans, dive to great depths, travel enormous distances, and return to specific locations at certain times of the year. That is why scientists began attaching small tracking devices to some marine animals to study their movements and behavior. These devices can record the animal's location, depth, water temperature, and even its movement patterns. Over time, this data can reveal migration routes, feeding grounds, and the environments these animals use throughout their lives. But what if we took this one step further? What if we didn't just know where the animal was going, but could actually see what it was seeing? Some animals can carry tiny cameras that record their behavior and surroundings, giving scientists a completely different perspective on life underwater. Instead of sending a vehicle along a path controlled by humans, we can let the animal move freely through its natural environment while the camera records what is happening around it. This can give us access to places and behaviors that are difficult to observe using traditional methods. But does that mean we can finally see everything that exists in the deep ocean? Not so fast. The devices need power, cameras need storage, communication underwater is complicated, and the animal's behavior may even change because of the device itself. And on top of that, recovering a device from a vast ocean can be extremely difficult. Most importantly, even if we combine all these technologies, one bigger question remains. How do we explore an ocean this enormous without having to search it point by point? Perhaps that is the biggest problem of all. The oceans cover about 71% of Earth's surface, but they are more than just a vast area. They are a three-dimensional world extending several kilometers beneath the surface, filled with complex terrain, while marine life, currents, and environmental conditions are constantly changing. That is why mapping an area isn't enough to say that we've explored it. Even a robot capable of diving to extreme depths cannot cover the entire ocean. It needs energy, must move from one region to another, and collects enormous amounts of data before repeating the process again and again, perhaps millions of times. This is where we begin to understand the true scale of the problem. We're not trying to reach one unknown place. We're trying to understand a vast, constantly changing world that covers most of our planet's surface. So the question is no longer, can we reach the depths? It's, how can we explore an ocean this vast without taking an almost infinite amount of time? And perhaps the answer lies in how exploration technology will evolve in the future. In the end, perhaps the problem was never that we couldn't reach the depths of the ocean. We already have. We've used submarines, robots, cameras, sonar, and sensors, and we've begun to uncover a world that remained largely beyond our sight for centuries. But reaching the depths doesn't mean we've been able to explore them completely. The ocean is vast and constantly changing, and what we can see on a single expedition is only a small part of a much larger world. And perhaps that's why every answer we find in its depths leads to another question. If this is what we've managed to discover so far, what could be waiting in the part we haven't seen yet? Subscribe to the channel, because our journey doesn't stop here. The next question might make you see the world around you in a completely different way.